Okay, now we're going to proceed with a test of our tool on 5.5-inch casing. This is the same tool as 7-inch. We're building a smaller one for 5.5 pipe. What we have here is the same elastomer elements as we use for 7-inch casing, except machined down for this particular weight of pipe, which is 5.5 14-pound J55. See, we're using 1.5-inch spacing. The distance between the elements affects the final diameter of the spaces between the bumps, but we'll talk about that later. And this is a sample of brand new pipe cut from a real dry pipe from a yard in Edmonton. So I'm going to we're going to go at 500 PSI increments, and I'll announce them at the various levels as we reach them.
Okay, here we go, guys.
Red dot across the screen. Dale Coons, the founder of Winterhawk, has a handheld temperature gauge. And as the steel starts to expand, we'll see an increase of temperature, and Dale will point this out to me as it occurs. At 500 PSI. Uh, 1,000 PSI. So we've got about a 1 degree average increase in surface temperature of the steel. And you can see now from the straight line across the back, we've got very distinct expansions occurring. Surface temperature is up to 1.5 degrees Celsius. The pressure is quit building up now at 1,250 PSI. And we're seeing that instead of building up pressure, we're actually not creating more pressure because we achieve ductility and the steel is moving as opposed to further compression of the elements. All the pressure now is going into the steel, not the compression of the elements. Yeah, the maximum pressure we got to was 1,500 and the pistons have bottomed out. So that's the end of the trail. Yeah, we're going to bleed the pressure off, open the tool, and then we'll caliper the expansion. The way we had set the tool is by pressuring up from the outside. We set the tool by pumping pressure down the inside. And this curved version, we put the pressure on the outside, on the other opposite side of the piston to pump it back open again. What we would do in the well bore is we would pressure up the annulus. We're duplicating that by adding pressure 1 of the 23 pistons in the setting tool. The setting tool is this version is 7 meters long and weighs about 400 kilograms. You can see the end of the mandrel starting to emerge. The tool pumps itself open. Now it's fully opened up. So the pressure's off. Okay, it's now safe to approach the tool. Corey, Hotzinger, Operations Manager, is going to caliper these babies.
The static diameter of the pipe is 5.55 inches. Our first bulge, 5.984 inches.
So that's about 9%. That's about a half an inch. The valley between the first and second bump?
5.558. So 8
1/1000th of an inch, really. Yeah, very little. The middle expansion is
5.801.
It's about 3/8 of an inch. Valley between 2 and 3.
5.55 inches again.
Same as, no change, really, same diameter. The bottom one?
5.899 inches.
All right, it's very close to half an inch. Corey, if you can grab the other end. I just want to show you how easily it slides off. What we're finding, and here's the elements thereafter. The two things I want to point out here. One is you'll see one of the areas we worried about was the possibility of having the element go beyond the retainer ring. So we finally found the right shape of the element and the elastomer such that we see no leakage over the edge or curling. And the other thing is the minimal amount of damage we did to the element, even though we had full expansion. And so we've been running these elements in the past where we run one element 4 times. We know we can get 4 runs out of an element every time with no material impact in performance in any way. We used to do 4 expansions, pick it up 6 inches over about a half a meter. What we now plan to do with 4 runs with this assembly, we would be able to put 12 expansions over a distance of less than a meter. So if we pick the right wellbore characteristics of decent cement on the backside with some firm rock against which we can get resistance, we will be able to put 1 contiguous expanded piece of casing across a crack or microannular leak. years. And we believe this is possibly the most effective assembly for this application ever invented. We think we're onto something here. We knew we had something with a single element. The 3-element assembly is a great step forward. So I want to thank you all very much for watching this today, and contact anybody at Tier 1 and Winterhawk if you have any further questions. Have a great day, and thanks for your time.